Hello, everyone, and welcome to the Ask the Expert webinar, How to Supercharge Enterprise Agentic Workflows with SAS Retrieval Agent Manager. My name is Thiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenters. First is Daniele Cazzari, a senior manager here at SAS. Daniele has a strong background in technical leadership and over 20 years of experience in IoT architecture across industries such as manufacturing, automotive, and insurance. And we also have Josh Anderson. He is a system architect in the SAS Global Process, Sensors, and Smart Practice. He joined SAS in October 2024 after working as a senior research and development engineer at Kitware Inc. Daniele, please take it away.
Thanks a lot, Thiago, for this wonderful introduction, and welcome to this Ask the Expert webinar. So today we are here to talk about SAS Retrieval Agent Manager, or in short, RAMs. You will say we pronounce RAM a lot of time during this presentation. Let's start now. RAM is a new SaaS product that helps organizations to build a context-aware AI agent, and this is done much faster. It's also grounding AI in trusted enterprise knowledge and turning insight into reliable outcome. So let's start with our agenda. So in today's presentation, of course, we are going to introduce what SAS RAM is, what are the main technology behind SAS RAM. We also show you the architecture and deployment option. Then I will turn over to Josh for a very interesting use case and very compelling demo. Stay tuned for that. And finally, we have a wrap up with all the key differentiation of the solution and the important point for this presentation. But let's start soon. Okay, so today, by the research of IDC and Garden, the 80 to 90% of enterprise data is unstructured. And this data grows incredibly fast, 3 times faster than structured data. But from the data we have, we know the only 25% of structured data was analyzed by artificial intelligence machine learning. And for the structured data, we know that it's even less. This created a very major content gap between data the company have and the insight they could really use. Closing this gap represents a huge opportunity. And this introduces us our first enterprise game changer of today's presentation. So in order to leverage this unstructured data, we introduced a new technology called Retrieval Augmented Generation, in short, RAGs, that combines semantic search and generation to ground LLMs to response in enterprise knowledge. Instead of relying on the model, the answers are built using trusted data. User questions are enriched with enterprise context, producing relevant and reliable response. Why really this matter? Because with this technology, the models really use your own data to develop the answer, and is able to cite all the sources and reduce a lot of the hallucination. Also, the data is always fresh, and we are always at the latest policies or latest specific answer without the time needed for retraining the model. This also really helps a lot with the governance, because this data could be siloed, and we could provide access only to relevant person that need to know, and because also auditing everything is happening. It is also very flexible architecture, because you are not locked with any specific model, and depending on use case, you may also use a small language model or different large language model of your choice. So but this, I think, is not enough. I mean, answering question is something we already know, but what if we could come from answer to outcome? What our question could really execute action? So we understood by the Gartner research that by 2028, the 33% of enterprise application will include agentic AI. That's in nowadays we know are much lower the number. In 2024 was just the 1%. And a parallel research from Gartner say that in 2028, 1/3 of the interaction with GenAI will be either with AI model, AI agents, or a model that's invoke actions. So this represents a fundamental shift from insider recommendation to end-to-end task completion. And this also led us to the second game changer, enterprise game changer of today's presentation. That are AI agents. AI agents combine reasoning and action. They don't just respond, but they help you to decide or could decide on your behalf and execute action. An agent brings together the powerful LLMs, some tools and policies and is able to move from a goal to an executed outcome. This enables system to operate with intent and just not interaction. So what does really matter to you? Because this helps us to move from answering a question to acting on a problem. Maybe set a trigger on a workflows, update a document, or really help or automatically make some decision on our daily activity. It's also very useful because these agents are personalized to context organizational information and not generic. And also one interesting feature of an agent that could really, with evaluation, could adapt very frequent on results and change as the strategy of your company change. And last but not least, governance still keep a very key role also in the agent, because you could, of course, secure and audit all your agent, ensuring that only people that need to know really access the information they have a right to. But what if we combine RAG and agent together? And this will lead to the agentic RAG. That really becomes our ultimate game changers. So this deliver goal-driven intelligence that are grounded with your enterprise knowledge. So combining the RAG pipeline, you ensure that insights are accurate, contextual, and based on trusted internal data. The agents turn those insights into decision and action using LLMs, tools, and policy. Together, they really move AI from information retrieval to grounded insight and executed outcome. This result is trustworthy and secure enterprise AI that scale across functions and companies. Okay, so with all this said, we could then introduce our tools, our SAS Retrieval Agent Manager tools that really enables to bring RAG and agent together and manage agentic RAG to build them, deploy them, and manage in production. And really turn enterprise data in actionable insight. It secure retrieve intelligence from unstructured but also structured data, grounding agent behavior in trusted sources. RAM orchestrated agentic workflow that combine RAG, LLMs, and tools to move from insight to action. It supports flexible data sourcing, so we could take the data where it sits in your company and integrate with multiple LLMs, small language, large language, as you need for your use cases, and the vector store of your choice. It has built-in evaluation, citation, and observability capability that ensure transparency, trust, and governance. And last but not least, support flexible on-premise and cloud deployment and also hybrid deployment. So that's really important to support different use cases. So let's try to understand how RAM works. RAM workflow starts by preparing document for the RAG. So the first, we are connecting with different sources, connection sources from your trusted internal area where you have your document. Then we organize and process your document to prepare a retrieval. This step is very important. So in these steps, we are, of course, converting your document for proprietary format like Word, PDF. Then we, of course, identify if there are images or there are tables. And we try and, with the provided intelligence, we are provide user OCR tools to extract information from image, or specialized AI tools to extract the tables and reconstruct them in a way that the LM could use and leverage them. Of course, you could make a lot of experiments with your data, and this leads us to the possibility to also run evaluation and choose the best settings, the best OCR, the best embedding model to convert your data. When you are able to define which is your best, this is done by testing with custom or your own made question that you could create on the platform, or automated question that we have our framework is able to create based on your data. And what is this important for? Because this leads to understanding how really your document behave is if are able to answer the question, if this is a problem of the model, maybe it's a problem of the fact that it's missing data, we need to add more information on the document. Then when we are happy with the result, we define our champions, and then this enables user to interact with your document. We are using a natural chat or API if you need to integrate with another application. And this leaded with LLMs that you could choose and you could suggest to the end user. But this might not be enough, of course. Some use cases require more complex workflow, and this leads to agents. And then how agent runs work in Run. Run enables teams to build AI agents that automate business process and workflow. Agents can be created using no-code tools, but also with optional Python code for custom logic. Also, the Python code will support the SAS via Python class that open the world to all the SAS proc that are being converted to Python. This also, the result of this agent are accessible with the same chat UI or the same API you used before for the RAG, so the experience is seamless. And the agent also leverages tool calling, so the possibility to call some external tools or function in VIA or a database to retrieve additional information or to run some algorithms that provide other important insight that will help our answer. It's also important that each agent runs in an isolated container, which has built-in observability for monitor and control. And then we are really working hard to make available the most flagship feature for the agent in the platform. So we'll be soon launching also evaluation for agent. That's in the same way that we do for RAG. We are able to understand which is the best agent, ask question, and check the question are really answered in the right way. And also we will ensure that agent might collaborate with other agents. So we'll implement the agent-to-agent protocol and the agent supervisor. During this call, during this webinar, you see me say a lot of time tool calling. Now let's deep dive a bit. What are tool calling? Tool calling is a technique that allows LLMs to decide when and how to invoke external tools as part of the reasoning. Then this combined with another technology called MCP or Model Context Protocol that is a standardized way for AI agent to securely discover, invoke, and interact with external tools. The workflow we see here, that I think this workflow will simplify a lot the understanding on the flow, how this works. Start with a question that could be done, of course, with a user or could be done through a machine. The agent then interpret this question and request and provide to LLMs the question, but also the context we get from RAG and all the available tools that we have listed for this particular agent. The LLMs analyze the request, analyze the data he has, and return a first answer with the list of MCP tools that need to use it with the relevant parameters. Then the agent run this tool, and MCP here really take a very important role is because the MCP will simplify a lot the way the agent need to run. In the past, you will, in order to run tools, you have to code everything in the agent. You have maybe to code a way to connect to a database, to code a way to connect to VIA. In this way, we could have a server that is pre-built and running, and the agent just need to connect and select the right tools with a really no-code experience. And this is able to run this information, retrieve the important data, and then we have if that's a possibility. So the data we get is enough, and so we go and combine it to an answer. Or maybe the LLMs say, okay, I need to be more precise to have a more important, more comprehensive answer. I need to run additional tool, or I need to run the same tool I ran before with different parameter. So this run in a loop that we see here, and that will conclude when we have enough information to give a really a wise and fundamentally good answer for you. Okay, this was a kind of introduction for the main things we have in SAS Retrieval Agent Manager, main technology, the main capability. Let's deep dive on the architecture and deployment options. First, RAM is a native Kubernetes application. This, as you may know, ensures scalability, security, and enterprise-grade operation out of the box. The user could interact with the application through a UI, that of course Josh will show you soon, but also possible to interact the application directly with the API engine. That is really hard, and This could be interaction with from additional external application, or you could link external chatbot. This engine, the API engine, is also responsible to streamline and arrange the workflow. So it will connect and monitor and manage agents, and also manage the vectorization jobs. The vectorization jobs are really the heart of the flow for managing the RAG. So the vectorization jobs are responsible to take the data PDF, convert them into text, chunk them, move the OCR, run a table extraction, and convert them, all this data, to vectors. So all this done on premise inside this job. These vectors need to be stored then in specialized database. So here we have the two databases we currently support in RAM that are Postgres, that's with the extension called pgvector, and DV8. That is a native database for vectors. Also, the RAM is able to connect with the LLMs of your choice. That LLMs could be on the cloud. You could connect through OpenAI API proxy or with the cloud-specific API, or it could be on-premise. In this case, you see here we show the Olama deployment as one of the options we could connect with. But also another very important point on the architecture, that RAM provides end-to-end traceability across the agent workflow. And it is visible in this picture we have here in the slide. So really, you could see when you make a query, we could really trace all the steps made in the query. And for the retrieval part, you could also find the document that has been used to make this answer and that be used in the retrieval, and show you also from where in the PDF this information has been taken from. Then this built-in observability really helps teams to understand how decisions are made and when action occurs. Because also, as you see, might see, maybe it's very small in this slide, but we also list all the tool calling with all the operation we made for calling this tool. And they really help us to debug or understand if something goes wrong, or understand why a given answer has been selected. We also support, as part of the platform, the Open Telemetry Protocol, also called OTEL, that enables standardized metrics, logs, and distributed traces. This really allows to seamlessly integrate with your enterprise observability platform and supports audit, compliance, operational monitoring. And as also very important, how RAM could be deployed. RAM is designed for flexible enterprise deployment and could be deployed across cloud or on-premise environment. We support for cloud, AWS, and Microsoft Azure. And for on-premise, we have currently support for BareOS or upstream Kubernetes. That will soon also include in the list Red Hat OpenShift. The current times, as we saw in the previous slide, run on Kubernetes cluster and need a Postgres database for metadata. This same Postgres database could also be used to store the vector information with a pgvector extension. But if we have a billion of vector, or really we need speed and efficiency, we could also rely on DV8, this native vector database that could run both on-premise and on cloud. So really, it's very versatile and very powerful for a big deployment. Of course, we also could connect as very important with LLMs endpoint. And as we said before, we support on-premise like Olama, but also the LLM through the OpenAI specs. And we support Azure Foundry and AWS Bedrock. And having said that, we have now covered the application. Let's look now how this comes to life in real-world scenario. I'll hand over to Josh, who will walk us through very compelling industry use case and very interesting and cool live demo on financial new agents in action. Over to you, Josh.
Thanks, Daniele. Let me just jump forward here. So yeah, real quickly, I'm just going to cover some of the use cases that we see with RAM. So that includes manufacturing, healthcare, government, and finance. The demo I'm going to be talking about will focus on a financial use case agent that we've built. But in general, RAM is designed to be highly flexible and generalized to many different use cases. So if you have unstructured data or even structured data, we might be able to help out. So with that, I'll jump into the demo portion. What I'm going to be talking about, just to give you a brief little introduction, is a financial daily news agent. And the goal of this agent is to generate a personalized financial newsletter for a specific client, maybe. And just as a note, I'm going to be talking about clients and like holdings information. This is all completely fictional, just for the purposes of this demo. And also in general, don't take this as financial advice. This is just to hopefully give you some ideas about what you could build in RAM and highlight some of the features that we offer. And a couple of the big things that I want to note before I get into the demo is data ingestion. So I'm going to talk about how you can use custom sources in RAM to go beyond just static local files and documents, but use those custom sources to fetch things like news articles from the web and ingest those into RAM. The second thing I'm going to be talking about is agents in RAM and how you can connect your agents in RAM to your knowledge bases, to your document sources, as well as tools via MCP, which Daniele had talked about before. So I'll show you how to actually do that in RAM. In this example, we're going to be using MCP to fetch client information from an application database to generate that personalized report. And then the last thing I'm going to talk about here is automation. So I'm going to show how we have the automation in RAM that lets you regularly set up, synchronize your data on a recurring schedule. That data then flows through to be vectorized, and ultimately how you can notify your agent to perform an action automatically. So starting with the architecture of the agent, I just want to highlight a couple of the big pieces that go into this. So the first piece is the daily news update. So that's going to be our custom source that I'll dive into later. The second major piece is the agent itself. And again, that's Python code running in its own container in RAM. So I'll talk about that. And then the last piece that goes into this is going to be the tools, the MCP tools that the agent has access to. And so I'll just walk through this diagram, show you how it works. So starting in the top left with the daily news update, what happens is we have an automated job that goes out and fetches the news articles from sites like CNBC, Yahoo, just websites that have like relevant financial information that we might want to vectorize. After we fetch those articles and save those into RAM, we vectorize them with the vectorization hub in RAM. And so that is the process that actually takes your documents, loads them, parses them, forms them into chunks, and then vectorizes them with an embedding model. So that's like the embedding part of the RAG pipeline. So after that process finishes, we'll have our embeddings saved into the vector database. And so we'll have a vector database that has, the daily financial news for every day. So we'll have those embeddings there, as well as for this demo, I added some financial documents like company 10K documents for the agent to reference. So after that process finishes, via automation, we will send a notification to the agent to say, hey, there's new data in our vector database. Can you please go generate a new report? And so what happens here in the agent initialization is we send a series of prompts to the agent to kind of guide it through the process of generating that personalized daily summary. So for example, one of the first prompts is, to the agent, we say, first, go fetch the holdings from the external client database for a particular client. So what happens here is the agent will use its MCP tools to go connect to this financial client database, which could live outside of RAM, because again, this is via MCP. So we're just connecting to that MCP tool and using that connection to talk to the database. So what happens here is the agent will go get relevant info like the client's portfolio, maybe what holdings they have, any recent transactions, so that it has that context when generating its report. The next step is we ask the agent to go fetch the current price info for the client's top holdings. So in this step, the agent, again, will use its tools to maybe use some of these statistical tools here. Maybe they'll use the real-time price info tool to fetch the current price of the client's top holdings. so that it can reference that in the report. And then the last step is we have a prompt to say, go search the knowledge base, so that news data that we've already vectorized. So go search that knowledge base and find relevant news from today for that particular client's holdings and generate that report. And so what happens here is, again, the agent will use its MCP tools. It should select the retrieval tools to do that vector database search. And whenever it does that search, what comes back will be relevant news information for that particular client. And after doing all of that, it uses that information to generate that report. It will save it into RAM. And then the user can go to RAM, see the report, and ask follow-up questions if they would like. And additionally, if you ask a follow-up question, the agent will continue to use its tools as appropriate. So it's got graphing tools if you ask it to generate graphs. If you're asking about like the performance of a certain stock price, it's got financial tools to get that info and help you to help generate that answer. So after going through all of that, I'm going to show you what this agent actually looks like in RAM. I'll show you the report, and then I'll show you each of these pieces and how you can do it. Let me just share my screen here. Okay. Hopefully that's sharing. Okay. Okay, should be sharing now. So this is what the RAM user interface looks like. So when you first log into RAM, you'll be taken to the dashboard page. And the dashboard page is showing you just kind of a snapshot of what's in the system right now. So you'll see here on this left-hand side, this collections menu. Collections are basically a grouping of source documents. So for example, the one collection that we're working with here is the financial documents collection. And you'll see this top table here. It lists different configurations. These are the different, basically vectorization settings that we've tested out for this particular collection. I'll go into more into that in just a couple minutes. Also on this page, I'll quickly highlight in the top right, we have our global settings. And this is where you actually can connect your large language models, your embedding models, and your vector databases. So you can see the different options that we support here for LLMs. The one I'll highlight here again is Olama, for those local model deployments. We support bringing in that. And then as well as Azure, OpenAI, and Bedrock models. For embedding models, similarly, we have Azure models that you can import and Hugging Face models, again, for those open weight types of models if you want to use those. And additionally, at the bottom, we have some pre-built Onyx models that are included in all RAM deployments. So these are the models that you can use and play around with whenever you're vectorizing to find the best set of settings. And then the last thing here is the vector database. So again, we have PC vector and mediate, and this is how you would configure that. So moving along, after after you bring in your LLMs and your embedding models and your vector database, the next step would be to actually add your files that you want to use. So to do that, I'll go to the sources page. This is showing us this top table, all of the sources that are in the system right now. So the one that we're looking at for this agent is this daily financial news fetcher. That's the custom source that goes out and actually fetches those news articles from the web. You'll see here the type is custom, but the other ones are local. And as well, we also support Git sources as well. So you can just provide your Git URL, and we will go fetch those files and post them at RAM. Custom sources, I'll just talk about just a little bit. Again, they're Python code that we allow you to bring in and write. We provide a very simple client for working with RAM, so for saving these files. But this Python code allows you to be very flexible and customize exactly what happens within this logic. And then the scheduler, that's how we say how often you want this code to execute. So you can say, I want it to run it daily at 12 a.m., for example. So for example, the daily financial news fetcher source is running daily in the morning, I think at like 6 or 7 a.m. And you can see at the bottom, this table is showing you the actual files that are in that source. So right now you can see basically every day's PDF containing the news for that day. And if I click on the file here, you can see the actual PDF that we generate from that source. So after you bring in your sources, the next step would be connecting those sources to a collection. to ultimately vectorize. So I'll go to the collections page. This is showing you all the collections we have here in the system. The one we're looking at is the financial documents collection. And whenever I click on that, we'll get taken to the summary table, which is showing us the different configurations within that collection. And so configurations are basically a subdivision of collections where it's a set of vectorization settings. So if I click on the new configuration button, you can see you can give it a name, whatever you would like. You can choose the embedding model that you want to use for that particular configuration, as well as the destination. And then we have other settings for like chunk size, chunk overlap, if you want to customize and test that out, as well as options for OCR and table extraction if your documents have scanned documents, or if you have lots of tables in your documents. You can use these to try to extract those tables. Now, after you create your configuration, the next step would be to vectorize that configuration. So to do that, you can just click on your configuration, click this button, and that will start the vectorization job, which runs in the background and actually generates those embeddings and saves them to the vector database. And one thing I will note for after you generate your embeddings, we have a nice little debug feature here where you can look at your documents that have been vectorized, and you can see the actual chunk content. So these on the left-hand side, we're showing the chunks that were made for this document alongside the actual source document itself on the right. So I can highlight chunks, kind of see what happened during the vectorization process. And if I wanted to here, I could also enable and disable specific chunks so that those chunks would not be retrieved whenever we're chatting with this collection. So it's a nice debugging feature to see what's happening under the hood. After that, the next step would be to choose your champion configuration. So you'll see I have 3 configurations listed here, all of them with a different name. The only difference between these 3 is the embedding model in particular that I use. So that's why I named them these particular names. But you'll see they all have this auto eval score and user eval score. And so these are 2 of the ways we help you choose a champion configuration, which is basically the best set of settings for your particular collection, your particular documents. So auto evaluation, like the name implies, we use an LLM. It's called Ragus is the framework. We use that to automatically come up with a set of test questions and answers, ground truth answers. And then we use that test set to compare the performance of each configuration. Similarly for auto eval, instead of an LLM coming up with questions and answers, you yourself can write those questions and have assertions in the answers to help verify that your pipeline is doing what you want it to do. So after you choose your champion configuration, you're free to go chat with it and try it out, right? So I'll go to the chat page to show you what that looks like. So go to chat here on the left-hand side. I'll choose the financial documents collection. Let's say the main GTP. You can choose the LLM that you want to use for that conversation, as well as the specific retrieval settings. So this is things like system prompt, top K, things like that. So I'll do a simple query like let's just see what products does Apple sell. So it should be something that's in the documents that we've uploaded to the financial documents collection, just to see that this is working and that we're using the vector data as appropriate. So we'll see we get the answer. And if I click on the query details button here, we can see exactly what happened. So we can see the overall cost and time, as well as the actual chunks that we retrieved from the documents. I click here, we see we retrieved 20 chunks from 2 documents. And then if I want to, I can go highlight the actual chunks that were used in generating that answer. So this is all well and good, right? But we're not generating that newsletter yet, and we're not using MCP tools. So now I want to show how you can take this and add tools to it to make that personalized newsletter, right? So before I do that, though, I have to cover tools. So tools in RAM, there's 2 types that we have. There's code-based tools, which are Python tools that we allow you to write in RAM. And then there's container-based tools. If you have a container that already has your tools, we allow you to provide the URL, and then we'll just host that RAM for you. So the tools that we're looking at for this financial demo are the finance tools. So I'll click on this one. I'll show you the code briefly. We provide a very standard decorator for this tool decorator to define your individual tools. And then within the Python code, you're free to write whatever you like. So for example, this fetch current price tool is using Yahoo Finance to find the actual real-time prices for a specific set of symbols. And then you can provide your external dependencies here. The second type again is container, and that one is a lot more simple. It's just you provide the URL of the image that you want to use, and we'll bring it in and we'll host it in RAM. After you do that, you can look at the tool servers. You can see the status of them in the tools MCP tools page. So if I go here to the finance tools, I can see the individual tools for that server, as well as the server status. You can start and stop individual tool servers. The next step would be then to create an agent and actually connect it to those tools. And so the agent that we're looking at here is the financial agent MCP. If I click on the edit button here, and you'll see it's running, so you can start and stop agents because these are just their own individual containers. If I click on the edit button here, you can see what goes into that agent. So you can give it a name, a description, and then the main logic is in the code, right? And we do provide some very good templates to start you out with the code. If you would just like a tool calling agent that just has access to a couple tools, then you don't even need to edit the code. But in this one, I do have a couple of some custom logic just to generate that daily report, which you can see here, this generate daily client summary. You can see exactly how I'm prompting it, right? I break down the problem into multiple prompts, right? So I'm saying first fetch the current investment holdings, then fetch the price, and then finally generate that report. So you can see the exact prompts that I'm using here in your code. The other tabs here are pretty self-explanatory, so you can choose the LLMs that you want your agent to use, the collections that your agent has access to, and then the last one here is the tools. So this is saying that this financial agent is using these finance tools from that finance tools server. These are the Python tools that I was showing. It's got some database tools for reading that client database. So this is like executing SQL queries, listing information about the tables so the agent can find that information, and then some charting tools as well for generating charts and things like that. And then the last one here is those RAG tools. So this is how we're doing that semantic search of our news documents that we were looking at earlier. This is how the agent can connect to those via these RAG tools. So after you set up, you configured your agent, you're free to go chat with it. So let's go back to the chat page and go instead of chatting with a collection, we're chatting with an agent. So you can see I'll just select the financial agent with MCP, start a new agent session, and immediately you'll see this wall of text. And I'll talk about that in just a second. But first, I just want to start a query here. So let's say I'm the client, right? Patricia Clark. So let's say, what are my top holdings, right? Let's just as a simple thing, just to see what are my top investment holdings. While that's executing, I just want to show this. So this is actually that client update that I was talking about. So you see it's got today's date for Patricia Clark, and then it references basically her top holdings. So apparently she has 313 shares of Apple. It's got the current price, and then it's referencing news articles that actually came out today. So you'll see, I guess Apple stock rose over 2% today. Maybe that was yesterday as of close. And then it's referencing just general things in the tech sector that came out in the news. But it is tailored specifically for this specific client. Let's see, this is still going. This could take a little bit depending on the LLM you're using and how many tool calls it has to do. But it looks like it just finished, right? So I asked, what are my top holdings? And then it says, here's your top holdings by value. That all looks pretty good. But if you want to see exactly how the agent arrived at that answer, again, we can go to the query details view. and we can see this top level query and the top level response. But then on the left-hand side, if we wanted to, we could drill down into each of the different queries, each of the different tool calls, and see exactly what happened. So it looks like first it was trying to find the ID for Patricia. It looks like it tried another query. Actually, there was an error in that query, so it had to retry. Maybe it had to get some more information about the schema for that table. But you can kind of see how the agent works its way to the answer. And ultimately, you can see where it got her holdings information from the database. Now, if I wanted to, I could ask a follow-up question and be like, could you show that in a chart? And again, we should see that the agent should take that query. It should say, okay, I have my charting tools that I configured earlier. Let me use that and basically take this previous conversation context and show that in a chart. And there we go. There's our graph that we built that was generated using our graphing tool, as well as a nice little description showing you the graph. And if, again, you can look at the details, see the exact query, the tool call, the input to that tool call, and then the output to of that tool call. So that is the financial agent. So hopefully that that whole flow made sense of showing you how you can go from ingesting a source document, creating a collection in RAM, evaluating that collection if you wanted to find a champion, using that for a chat, and then ultimately creating an agent with MCP tools to customizable for your needs. So with that, I will stop sharing and go back to the presentation. Okay, I guess Daniele, I'll toss it back to you.
Well, thanks a lot, Josh. It was very, very interesting. And see, we saw really the powerful of this tool. Thank you very much. So let's, before concluding, I would like to show a final use case. This is an industrial use case, and it will help us to really move from anomaly detection to action. So for a long time, SAS helped a customer to identify potential failure early through predictive and proactive maintenance. But as we know, industrial environment, alerts still lack of context. So operation might receive too many signals or might not have enough knowledge to react to them. Root cause analysis require manual interaction, and the response time suffer. Also is really linked to the availability of some subject matter expert. So with RAM and the LM-based agent, we were able to change that. So what we did, we collect all the operating and machinery manuals, historical incident, and past resolution, and we build a RAG against this. And then an agent that is able to reason over this context, over this information, and interpret the error signal that comes from the IoT machine, and return an explanation of why this is happening. And not only, but also generate a ranked solution option based on the historical information we have with some corrective plan. There really is a way to distribute and democratize the knowledge inside of enterprise. And this also results, really, of course, as you may know, as a faster movement from detection to correction, removing a lot of manual effort that will consist to read manual and check the story of a resolution. And having said that, I think it was very interesting also this use case to show to you. Let me go to a small recap on our today's session. So we now learn what SAS Retrieval Agent Manager is. Let's also deep dive and recap a bit of the key differentiation we see on today's presentation. First of all, is the time to value, of course. RAM accelerated the path from the proof of concept to production, and this is thanks to this no-code approach that span to the agent and, of course, the RAG with a really intuitive RAG user experience. And that also is very useful because it has an easy MCP tool integration, so we could really leverage the capability that might be in the company on other external tool. The solution is also the application is fit for purpose. So is designed for real enterprise users, allowing you to chat with your, or also using API directly for connecting with your RAG and your agents. Enable to bring your own LLMs and embedding to tailor your specific use case that could be on-premise or on cloud. So we really give you full flexibility on deploy your use case where you need. Then the solution enables you to answer the answer you could trust. RAM ensure transparency, I will see accuracy and confidence through clear source citation and agent that will be available soon, but RAG evaluation that is already available, that improved quality. And also we could introduce the human in the loop in the flow whenever it's needed. Finally, but not less important, is the operational resiliency. RAM provides full agent control and observability. It also automates the continuous gestion of new RAG data. So if you are updating your document, we have strategy to keep the RAG updated with your document in an automated way. Keeping all the time, you will have the last information available to have very ultimate response of the problem. And also, we enable to manage the agent lifecycle end-to-end, also alerting agent if new data arrives to allow them to move on the loop. And I will say that really thank you for attending the presentation. And if you have any question, I give over to Tiago to see what the audience is asking.
Thank you. Yes, with that, we will be moving into the Q&A segment of the webinar. All right, now on to our first question here. This person is saying, when you say for a defined period, what is captured and how is it protected? Who manages keys? Is it BYOK?
Okay, so and I will take this on, like I think it's starting with the previous question. So it's how the security works in RAM and how it's managed currently. So I mean, RAM manages security through permission. So everything. So you see the collection, you see the item, everything is go through permission. So we are so the admin, of course, has a possibility to share and see and collaborate, but each user needs to have explicit permission on the data, and also all the data is audited and logged. Then for this login, every setting is made by the system administration. So the retention time, the period of course the needed key, everything is made by the Kubernetes administrator. So this makes everything secure. It's not possible to interact this as a normal user.
Thank you. On to our next question here. Someone's asking, what is the difference between notebook, LLM, and RAM?
Yeah, I mean, thanks for this question. I think also we could extend this. What is the difference with Copilot and RAM? So I mean, notebook, LLMs, and Copilot typically helps individual user to summarize document, to generate answer from general knowledge. With SAS Retrieval Agent Manager, we are trying to build a global chat for your enterprise. So when questions come in, there is a specialized agent you build that rely only on data governed from your enterprise and apply analytics or business rule. And then you produce an answer that you know because you tested, you evaluate, you configure in the right way that is traceable, consistent, and really back to your business data. So instead of just helping in a response, you get an answer that you actually can use to support operation and regulatory decision.
Perfect. Thank you. Someone's asking, they're saying, we have some company internal trained and secured LLM, which we can use with API calls. Is it possible to use these kind of models in SAS RAM?
Sure, yeah, this is absolutely how SAS RAM has been built. We support out of the box the OpenAI API spec that is usually the standard where how this model are deployed, but we are happy to discuss with every you if you have any custom solution for deploying this model to make them integrate. We are really able to manage and leverage mostly every model through API.
Perfect, thank you. Someone's asking, how is your solution different from Microsoft Copilot?
think I had an answer before. So yes, really the fact that I think it's the same as notebook LLM. So really the fact that instead of working for one person, we are working for the enterprise. So we produce a result that could be reused across multiple users in your factory, in your the chatbot that you use for the front end, and are really traceable and trusted that they always use the right information that you could evaluate and check and test over time.
Apologies. Yeah, that was similar to the previous question. Another one here. What input file formats are supported by SAS RAM?
This I leave to Josh.
Yeah. I actually have a table here. I'll share my screen real quick. Oops. Sorry, the share button is different than Teams that I'm used to. Okay, let's see. Let me know if you can see that table okay.
Yes.
Yeah, so we've got most like basic file types like PDFs, Word docs, Excel files, as well as like source code if you had that. You can see the full table here, as well as you'll see the files that we support OCR on and extracting tables for. So you can find all of this, the documentation too for RAM.
Would it be possible to zoom in just a little bit on that as well?
Oh, yes.
Perfect. Thank you. Yeah, we'll have that up while I ask this next question. Is SAS Retrieval Agent Manager available in SAS Viya?
Yeah, I take on this question. Thanks, Tiago. So I mean, we at the moment, SAS Retrieval Agent Manager is a standalone application that, of course, could connect and could leverage all the information from Viya. We are working with the R&D department to also make available this functionality in Viya, and that will be, stay tuned because we might announce something soon.
Perfect. Thank you. Someone is asking, how about CAS datasets?
Yeah, thanks for the question. So yes, this is really the beauty of the MCP and the tool calling. So we are able really to leverage it. Maybe you saw. If not, we could send in the answer in the GitHub from SAS. We are deploying some MCP tool to connect with Viya. RAM is fully able to connect with MCP tool and run and get data from CAS table, or also get storage procedure you might have developed and have the full usage of what you have in Viya that you might need to get the answer.
Perfect. Thank you. I'm afraid that's all the time we have for questions today, but if we did not get to yours, we'll answer all unanswered questions in our follow-up communities post. Thank you, Daniele and Josh, for your answers, and thanks to everyone in the audience for joining us. On behalf of myself, Daniele and Josh, and all of SAS, we really hope they enjoyed today's webinar. Thank you all, and have a great rest of your day.